Hello sir, morning everyone. Here today we are going to discuss about the topic is hybridization. Sir, here hybridization. So what is the definition of the hybridization? That is the intermixing of pure orbitals. The intermixing of pure orbitals to give an equivalent orbitals. To give an equivalent orbitals, which are called equal in energy and equal in shape containing orbitals. A set of new orbitals which are called hybrid orbitals, and the phenomenon which is called hybridization. Sir, what is the definition? The intermixing of pure orbitals to give an equivalent set of orbitals which are called hybrid orbitals, and the phenomenon which is called hybridization. Right, sir? Here we have sp2 hybridization of the carbon. What is the best example for the sp2 hybridization of the carbon means, which is a ethene molecule. Ethene molecule we can write as a C2H4. What is the formula? C2H4. In organic chemistry, here ethene means here one of the alkene. That is, here there is a suffix "ene," which represents there is the presence of a double bond in between carbons. So we are going to discuss about the molecule which is containing a double bond. Right, sir? Here, what is the electronic configuration of the carbon? And what is the atomic number? That will be 6. And what is the ground state electronic configuration? Ground state electronic configuration of the carbon, that will be 1s2, 2s2, 2p x1, 2p y1, and 2p z0. We can represent like this: 2s2, 2p x1, 2p y1, and 2pz will be the vacant orbital. 2pz will be the vacant orbital. Sir, in this ground state we have only 2 unpaired electrons. Already I said number of unpaired electrons, which are the criteria for the number of bonds, that is number of covalent bonds. So that's why here carbon can undergo excitation to get 4 unpaired electrons in their valence shell. So here it is said to be clearly 2s2, 2p2 will be the valence shell electronic configuration. So that's why here we have this promotion of electron can takes place from lower energy level to the higher energy level, because according to n plus L values, 2s is less energy than that of the 2p set of orbitals. So that's why shifting of an electron can takes place 1s2 to s1, and what will be the electron configuration? 2s1, 2p. Right, sir? Here carbon can undergo excitation state for the promotion of one of the electron from the 2s subshell to the 2pz subshell. Right, sir? Here in this ethene molecule, here there is a hybridization takes place like this. For the involvement of the, by the involvement of the only one 2s electron and 2 2p orbitals. Okay, for the formation of, by the involvement of one 2s subshell and 2 2p subshells, for the formation of sp2 hybridization. sp2 hybridization. Okay, in our methane there is a involvement of one s orbital and 3 2p orbitals for the formation of sp3 hybridization. But in case of ethene molecule, this is different. There is an involvement of only one 2s subshell and two 2p subshells for the formation of sp2 hybrid orbitals. Okay, sp2 hybrid orbitals. So we can see the energy level diagram of the carbon will be here, energy, and what is the ground state electronic configuration of carbon? That will be 1s2 and 2s2 and 2p2, that is 2px1 2py1. Then by the promotion of electron from lower energy level to the higher energy level, carbon can undergo excited state. So what is the electronic configuration? 1s2, and by the promotion of electron can takes place from lower energy level to the higher energy level. So that's why what is the electronic configuration? 2s1 2p3. We can represent like this. In ethene molecule, each carbon can undergo sp2 hybridization only. sp2 hybridization only by the involvement of only one 2s subshell and two 2p subshells. Hybridized state, that is 1s2, and there is a set of orbitals which are all are said to be sp2 hybrid orbitals, and all are containing at least with a one unpaired electron, and there is a no involvement of 2pz orbital in the hybridization, which is called pure orbital, unhybridized orbital, or a pure orbital which is not participating in the hybridization. Right, sir? Here like this. So here we have, these are three equivalent orbitals which are all are equal in shape and equal in energy, containing one, which are called hybridized orbitals. Right, sir? Their energy is same, their shape also same, but they are oriented in the space. To minimize the electron repulsions. They are arranged trigonal planar manner. So that's why here each carbon containing, right, three hybridized orbitals which are arranged trigonal planar. So each orbital contains with one unpaired electron. So this is the one of the carbon, and another carbon, they are also arranged trigonal planar. So each orbital with one unpaired electron. So they are going to bonding with the hydrogen molecule. So what is the hydrogen molecules? So hydrogen electronic configuration is 1s1 because atomic number is 1, and then 1s1 is the electronic configuration of the hydrogen. So what is the shape of the s orbital? That will be spherical in shape for the formation of a sigma bond by the head-on overlapping. So hydrogen's s orbital and sp2 hybrid orbital of the carbon, they are going to head-on overlapping manner for the formation of a sigma bond, that will be sp2. There is a formation of sp2 sigma bond. Here total number of bonds which are 4. So total number of bonds, that is there are 4 sigma bonds which are overlapped by the involvement of s orbital of the hydrogen and sp2 orbital of the carbon for the formation of 4 sp2 bonds. And there is a presence of another sigma bond formation takes place by the involvement of sp2 hybrid orbital of the one of the carbon and sp2 hybrid orbital of the another carbon. They are also in the head-on overlapping manner for the formation of what, Nana? Sigma bond formation takes place, sp2 and sp2. Right? Here there is a notice. Okay? Ela anante in ethene there is a presence of a double bond in between 2 carbons. One of the bond which is known as a sigma bond by the overlapping of the sp2 and sp2. Right? Another bond is pi bond. So pi bond formation can takes place by the side to side overlapping of the unhybridized or pure orbital overlapping can takes place. Sir, how they can represent? They can represent which are perpendicular to the plane of the trigonal orbitals. They are perpendicular to the molecule. So each containing one orbital containing one electron. So they are going to overlapping with each other by side to side overlapping manner for the formation of what, sir? There is a formation of a pi bond can takes place. Okay, we can represent the structure of the ethene molecule. There is a sigma bond between carbon and carbon and carbon bond hydrogen, bond hydrogen, bond hydrogen, bond hydrogen. So they are look like a fan. Ante kada? So center lo unna edaithe motor undo, that is carbon, 3 wings. One of the wing is hydrogen, another wing is hydrogen, and another wing is will be carbon. So they are just represented as a equilateral triangle. Okay. Like this. And there is a formation of a pi bond by the head-on. There is a formation of a pi bond by the side to side overlapping of the p orbitals for the formation of a pi bond, and there is a sigma bond. Right, sir? What is the bond length? Here we have 4 carbon bond hydrogen bonds, all are same. So what is the bond length? Means here 1.09 angstrom units. 1.09 angstrom units. And there is a presence of 1 carbon bond carbon single bond, that is double bond we can represent with the 2 bonds now. So that's why what is the bond length? That will be 1.34 angstrom units. In case of methane or in case of ethane, there is a carbon bond carbon like this, 1.54 angstrom units. In ethane we have 1.54 angstrom units, but in case of ethene, which contains a double bond, here what is the value? 1.34 angstrom units. The shortening of bond can takes place by the electron cloud which is present in between carbon and carbon. So that's why there is a shortening of bond can be takes place. With respect to that, carbon double bond carbon, what is the value? 1.34 angstrom units. And what is the bond angle? Bond angle will be here 120 degrees. 120 degrees. So what is the shape? Trigonal planar. Trigonal planar is the shape of the right sir? Here carbon can undergo sp2 hybridization only. There is no involvement of third orbital of the 2p subshell, that is 2pz will be the unhybridized. Okay, unhybridized orbital, so that there is a formation of a pi bond. Loss in the pi bond formation, only unhybridized orbital తో వస్తుంది in the manner of side to side overlapping. Okay, thank you.